Today, we're going to create equations to parallel and perpendicular lines. Write an equation for two different lines that are parallel to this one, parallel to the one shown. So first, let's identify the equation of the line shown. I'm going to find the y-intercept. Looks like that is 4. And I want to find another point. Here's 1. Here's my slope triangle, delta y. The height of this triangle is 3. Delta x, the width of this triangle, is 4. And as I look at this line from left to right, it is going up, it is increasing. So my slope is positive 3 over 4. This equation is y equals 3 over 4x plus 4. So now I need to write an equation for two different lines that are parallel to this one. Now, parallel lines have the same slope. So I already know the slope of my lines will be the same as the slope of this line, which is 3 over 4. Okay, so 3 over 4 times x, 3 over 4 times x. Now, right now, these are the same line, right? Y equals 3/4 x. I need to write two different lines, and they can't be the same as this one. Well, the one that is pictured has a y-intercept of 4. So as long as I don't put a y-intercept of 4 on either of my lines, I've written two different equations. So I'm going to say plus 1 minus 5. There are so many possibilities. Let's go ahead and graph these to check. The y-intercept is 1. The slope is 3 up 3 over 4. Three-fourths x minus 5 is down at negative 5, up 3 over 4 again. All right, those lines look good, but guess what? It's not enough just to say they look parallel anymore. We have the tools to be able to describe how we know these are truly parallel lines, and it's based on the slopes. So how do you know the equations you wrote are parallel lines? The equations I wrote are parallel because they have the same slope. Parallel lines have the same slope. Write an equation for two different lines that are perpendicular to this one. Oh yay, it's the same equation, the same line as the one above, so we can write that equation. Y equals 3/4 x plus 4. And slopes of perpendicular lines are opposite reciprocals. So we need to find the slope that's perpendicular to the one given to us. The slope given to us is 3 over 4. We need to find the opposite reciprocal. Opposite means to change the sign. This one right here is positive, so our slope will be negative. And reciprocal means to flip the fraction. So instead of 3 over 4, our fraction will be 4 over 3. So our slope of a perpendicular line is negative 4 over 3. Negative 4 over 3x will be my slope. Now I just have to pick y-intercepts that have not already been used. I see that 4 has already been used, so I'm not going to add 4, but I could subtract 4. And I could add 0. Adding 0, you don't even need to write that. Wow, that was even easier. Okay, so let's graph them to check. The y-intercept of our first line is 0, and the slope is negative 4 over 3, so down 4 over 3. Let's go up 4 to the left 3 and connect those dots. Our second line has a y-intercept of negative 4 and has the same slope as the other line we wrote, so down 4 over 3 or up 4 over 3. connect the dots. Ooh, these do look like they are perpendicular lines. I think these are making right angles. But it's not enough for us to just look at it. We have to be able to prove it based on the tools that we have. And the tools that we have tell us that perpendicular slopes are opposite reciprocals. So how do you know the equations you wrote are perpendicular lines? Well, the equations I wrote are perpendicular because the slopes are opposite reciprocals. And they're not opposite reciprocal slopes of each other, right? Actually, the two lines that I drew, the equations that we came up with, those are actually parallel to each other. So the slopes are opposite reciprocals of the line that was graphed, that purple line. Write an equation of the line that goes through 2, -3 and is parallel to the one graphed. All right, parallel slopes are the same. So I just need to know what the equation of the line graphed is so I can get that slope and then write the new equation by graphing that. My y-intercept looks like it's -7. I think I have another point at -1, -1. My slope triangle has a base of 1 and a height of 4. And as we look left to right, this is decreasing. So our slope will be negative delta y over delta x. You could also write that as -4. So our equation for the line graphed is y equals -4x minus 7. So what is the slope of the new graph that we're going to make? What is the slope of that going to be? Well, the slope of line A is -4. Parallel slopes are the same, so the slope of line B should be -4, or -4/1. All right, I don't know the y-intercept, but I know another point, 2, -3. So I'm going to graph that point. And from that point, I'm going to count my slope, the slope of line B, down 4 to the right 1. Okay, and then up 4 to the left 1. Up 4 to the left 1. All right, we have a y-intercept. That is 5. Connect your dots. So the equation of our line is y equals -4x plus 5, or -4/1x plus 5. Write an equation of the line that goes through 2, -3, and is perpendicular to the one that is graphed. Perpendicular slopes are opposite reciprocals. Okay, so first we're going to find the equation of the line that is graphed, and then we can take the opposite reciprocal to find the slope of the equation that we need to create. Here I see a y-intercept at -6. Ooh. I only see one other point here, maybe one down here. This slope triangle has a height of 2, and it goes from 0 to 7. Ooh, the base of this triangle is 7. And as we look from left to right, this line is increasing, so the slope should be positive, delta y over delta x, 2/7. The equation of the line graphed is y equals mx plus b, so slope times x minus 6. The slope of our line is 2/7. So what is the opposite reciprocal of 2/7? The slope of our line is positive, so the opposite would be negative. The slope is 2/7, and we need to take the reciprocal, so flip that to be 7/2. So the slope of our perpendicular line should be -7/2. I do not know the y-intercept, but I do know another point. So I'm going to graph that point. And from there, I'm going to count the slope. Down 7/2. 3, 4, 5. Oh, no. not enough room. So this time I'm going to go up 7 and then to the left 2. 1, 2, 3, 4, 5, 6, 7 over 2. And we do not have room for another point, so connect those. And our y-intercept appears to be 4. So the equation of our line is y equals negative 7 over 2x plus 4. So to recap, writing an equation parallel or perpendicular to the one graphed, we would need to find the equation of the graphed line, identify your slope, whether it's perpendicular, opposite reciprocal, or parallel, the same slope, then graph the new line through the point they've given you with the slope you have, and then write its equation.